All right, so I tried pulling some problems that I think you were having issue with from your MyApp of Math. There's some from the practice problems. I think there's one from the problem set. So if I'm missing anything you still want to see, you can just let me know. But this is question 4. I think this is from practice problems. But it says in demand and supply problems, Y is the number of items in the public will buy if the price is an item X. In particular, if the price is $28, the public wants to buy 501. However, if the price is 51, they only want to purchase 340. So you came up with these coordinates correctly. So I'm going to show you first how to come up with the equation by hand. And then since it seems like you're comfortable with linear regression, I'll show you you can just use linear regression to find this equation as well. But what we're going to do first is say, all right, well, I want my equation to be in the form y equals mx plus b. So I need to first start by finding m. M is going to be my slope. So we have that slope formula, which is y2 minus y1 over x2 minus x1. So my slope is going to be y2, which we'll say is 501, minus 340 over, and make sure you have the corresponding x underneath the corresponding y. This is going to be 28 minus 51. So I get on top, let me pull my calculator up. Forgot to get that up. Okay. So here we have 501 minus 340. That's going to be on top, and we have 21 or 28 minus 51. So we have 161 over negative 23. 161 over negative 23. Now, if you reduce that, that's going to be negative 7, which is nice. So there's our slope. So now I still need to find b. So I'm going to take this value for m. This is my m. And either one of my xy's and solve for b. So I'm going to use this xy combination. So when y is 501, m is negative 7, my x is 28, and now I'm going to find b. So I get 501 equals negative 7, 7 times 28, negative 196, plus b. So now I'm going to add 196 to both sides. I think I see what the issue was. If I do 501 minus 196, yeah, that was where the mistake was. This is a negative 196 because your slope was negative 7, negative times positive and negative. So in solving this, you should be doing 501 plus 196. So that gives me 697. So that's where the issue was right here. Small mistake. That's a problem with these online websites. You can't really tell where the mistakes were made. So the actual answer is going to be negative 7x plus 697. Okay, you can use the linear regression procedure. You're just going to plug each of these x, y's into your stat list. So let me clear that out. If you go to stat, edit, clear out everything in there. If I put the x values in here, 28 and 51, and 501 and 340, my stat, calculate linear regression. This is what you would do for a normal linear regression problem, and you'll see that you get y equals ax plus b, where a is negative 7 and b is 697. So you get the same thing by using this method as well. Okay. Moving right along, I think this is from the practice problems as well. So it says X is the number of items, Y is the money. If the fixed cost for certain items is $190 and it costs to produce each item is $6, perfect. 6 times the number of items plus $190. Your retailer intends to sell them for $10 each. I think you might have combined or tried to do more here than you needed to. We're keeping these separate. So this is its own equation for cost. Our revenue is just going to be equal to how much we make per item. This is just going to be 10x. So that changes that. Okay, so if this week 42 items are made and all are sold, the cost function, we're going to take 42, plug it into the first equation. 6 times 42 plus 190. That gives me 442. The second equation you get by plugging 42 into this guy, which gives you 420. Now, just something to keep in mind, because this will pop up in chapter 2 as well. Profit is equal to revenue minus cost. So in this case, profit is equal to the revenue, which was 420, minus the cost, which is 442. So my profit is going to be negative 22. Okay. And I believe there's one more with, oh no, we have another one here. So same thing here. Don't overcomplicate this. I'll just give you this guy. The first one you got, no problem. Again, keep these separate. This is just going to be y equals 13 times x. So to get the cost, we're just going to plug in 63 here, write down what we get. To get the revenue, we're going to plug in 63 here, write down what we get. And then for the last one, just remember profit equals revenue minus cost. You can think of the word price. That's how I remember it. Price, PRC. You can do the I here and the E here. P equals R minus C. And this last one, select all the following graphs which represent a function. The only real way we know how to show if something is a function when given the graph is the vertical line test. Basically, if every vertical line I draw through that graph only hits it in one spot, then it's a function. So I'll just take a regular old vertical line, make it fancy, make it color, make it red. I'm just going to drag this over each graph. And if it ever hits it more than once, what I'm talking about is not a function. Notice here it only ever hits the graph once. So this would be a function. This is a function. If I take it over this thing, yep, it hits it twice here. So I have an issue here and here. So this is not a function. And then the third one, yep, if I drag it anywhere on there, it's only ever going to hit it once. So this is a function. And then here, like even though it doesn't hit it twice here, sorry about that, my phone is beeping. Even though it doesn't hit it here, if I move it over here, you'll see it hits it 3 times. So it hit it more than once. So this is not a function. This one here, if I drag it along, it looks like it might hit it twice, but it really only hits it once everywhere. Once. So that's actually going to be a function as well. And is this the last one? Yep. The horizontal line only ever hits it once, so your answer for this one is correct. That is a function. So again, if I'm missing anything that you still needed help on, just shoot me an email back, and I'll